Okay, so today we are looking at covering the topic which is called expressions. And when we look at this particular topic, what we need to do is understand equations and formulae. That is what expression is primarily used for. So let's get into a brief understanding of first and foremost, what is expressions. Now, when we look at, talking about expressions, expressions tend to be, a mathematical way of describing numbers, variables, and operators. So operators are typically things like, when you add, you subtract, you divide, you multiply, or when we use the rule which is called bod mass. I don't know how many of you have heard the rule which is bod mass, but in our initial days when we learned maths in year 10, we would have heard something called board mass. Now this when we talk about this particular term, board mass essentially stands for how you would it's a mathematical rule wherein basically it will under the full form of this is brackets order, then in sometimes when you have a lot of operators. So if I put this across here as well, when I talk about so a couple of things, operators. So when I talk about operators, operators are things like minus sign, plus, division, which we use, or multiplication. These are operators. So when we have to look at things like using these operators, we have to follow a particular rule. So BODMAS is that rule that we follow. So if you are having an expression, and when I say an expression, expression is basically a combination of numbers, variables, and operators. So an expression would be like 3x equal to 4x minus 56 plus, I would say, just I'm making it up. But what I will do is I will put this into a bracket here, and then say divide by 2. And then this is actually an expression. This is a way that we can express numbers, variables, and it is expressing them by use of what are called operators. So equal to is also an operator. So when we talk about operators, we talk about a rule called BODMAS, because BODMAS is a rule which allows us to understand how these operators are to be used, or in what priority or order these operators, essentially have to be used. So it is important for us to solve, when we solve equations, when we solve and use formulae, we would normally put them across as expressions, which will be an equation, and this equation will have what are called variables, and variables will also include operators which tell us exactly how we need to solve the equation. So if I give you an example of an equation, just to put everything into context, an equation is a mathematical statement that shows us two expressions by using an equal to sign in the middle. So I would say an equation would be 3x plus 5 equal to 11. This is an example of an equation. Example of equation. Okay. So when we look at this as an expression, what we get to see is that numbers and operators are being used to actually express, some sort of a mathematical value. And when we solve these, we are able to get an answer or arrive at a solution for these equations. Now, when I say formulae, would be, if I was to look at a formula, if I were to look at calculating, say, for example, area of the rectangle. Now, again, for calculating the area of rectangle, I would need to use an expression. An expression in this case will essentially be some numbers that I will use to calculate the area of a triangle. So if I were to draw up a small triangle here, say for example, this is a triangle, a rectangle, and I want to find the area of this rectangle, what I would need to do is I need to know the formula of how to calculate the area of rectangle. Now, area of rectangle, the formula is length into breadth. So if I write length into breadth or width essentially. So length is this portion, this side, and this is the breadth or the width. So if I were to look at finding out an area of a rectangle, and if this was the question which came in the exam, this would be given out to me as an expression with along with an image. It will say the area, you have to find out the area of the rectangle. But for that, to find that out, you would need to know the formulae. And again, if I say this is depicted by 11, and this part is depicted by saying this is 3 meter and this is 11 meter. Now if I know that what is the how what if I know the formula of how to calculate the area of rectangle, and I know the area of rectangle is length into breadth or width, then if I have the two values, then I can calculate the area of this rectangle as equal to 11 meter into 3 meter equal to 33 meter square. So this would become the area of the rectangle. So when we talk about expressions, equations, and formulae, they are used in mathematics essentially to help us in doing calculations. These calculations could be calculations related to numbers. These calculations could be calculation related to equations, or these can be calculations related to certain formulae which help us in understanding a relationship between different variables. So variables are length and width. This is a variable. So this is the context that we want to look at today in terms of covering our session. Now, what is BODMAS, which I talked about initially? BODMAS is a rule. It's a rule which we need to follow when we are trying to work with operators. And it means bracket of division, multiplication, addition, and subtraction. So if you were to have an equation like this, if I make this a small x, if you were to have an equation like this, you would actually solve this equation by using the BODMAS rule. That means first and foremost, you would have to look at division. You have to solve the division part of it in the equation. Then you will go to multiplication. If I change this to, then you have to go into multiplication, then addition, and then subtraction. Now, what are the operators here? Addition, division, multiplication, subtraction, and equal to. They allow us to actually put some mathematical numbers, variables into some sort of a display, whether it's the form of an expression or a equation. They can be done using the use of numbers and these operators. Now, if you have to solve this equation, how would you go about solving this equation? You have to basically look at solving this equation by following the BODMAS rule. So this would be looking at, following brackets of, first and foremost, you would look at doing division. And after you have done the division, first and foremost, bracket. So where are the brackets here? That means this number has to be solved first. This will take precedence. You cannot just solve the equation in a random manner. You have to look at this rule. So first and foremost, if there are any values given in the bracket, you have to solve that. Then after that, you would basically look at division. Then you would look at multiplication, then you look at addition, and then you look at subtraction. Now, if I were to solve this equation using the BODMAS rule, and if I take this to a new slide, just to explain, now this is what I was looking at solving. What I would do is I would start with the first step, which is basically looking at solving. The step one would be to solve the bracket, right? Because I'm following the BODMAS rule. So solve the bracket is 56 plus 72. So 56 plus 72, how much is that? Any idea? 56 plus 72 is equal to 128. So what I've done is I have first and foremost solved the bracket, which is 128, right? So if I have to rewrite this equation, this will become 3x equal to 4x multiply, and then in this it will become 128 divided by 2. Now, after the brackets, the first operator which comes is division. So what I would need to do is divide. Step 2, I have to divide 128 by 2, and that would be 64. So if I have to rewrite the equation now, rewrite the equation. So rewrite the equation would be 3x equal to 4x multiplied by 64. So the equation we have simplified. When we started, this was the equation given to us. Now we have simplified the equation to this. Now, after division and after multiplication, what do we have now is basically we need to solve, after division, we need to solve multiplication. So what I'm going to do now is, because these two are similar variables, 3x and 4x, what I'm going to do is I'm going to use and basically transfer these variables in a way that it can align, to give me a simplified equation. So step three, when I have to solve, so if I say step three, and I have to solve multiplication now, because you have 4x, which is a variable, multiplied by 64. What I'm going to do is, so I'm going to write 3x equal to 4x multiplied by 64. And how do I solve this? What I will do is basically, what I'm going to do is, I'm going to say 3x equal to, so what I will do is, because 64 is on one side and I need to look at this number, so 64 times 4, you know, what is 64 times, so if I look at 64 times 4 is 256. So if I multiply now 4 and 64, that will be 256x. So I have solved multiplication now. Next step would be, after multiplication, we don't have any addition, we don't have any subtraction, but now what we need to do is find the value of x. And we have an operator in the middle called equal to. So we need to look at how do we find the value of x. So the equation right now is 3x equal to 256x. Now, in order to isolate x, what we need to do is we need to subtract 3x from both the sides to make the value 0. So what I'm going to do is, because both these sides have x, so if I do one thing on one side, I have to look at repeating the same thing on the other side, and I will say 256x minus 3x. Now, this is a simplified way of writing the same equation, because 3x minus 3x, if I'm subtracting the value of 3 here, then I will subtract the value of 3 on the other side as well. So here, this would, on this side, 3x minus 3x will become 0, equal to 253x. So how would I find out now the value of x? The value of x would be, I will move the number 253 to the other side, 0 divided by 253, and that would be anything divided by 0 by any number is equal to 0. And that is how I will solve this equation. So when you get equations to solve, and you have equations which include operators like equal to, plus, divided by, multiply, subtract, or equal, then what you have to do is you have to keep simplifying till you reach a particular answer. So in this case, if I had to simplify this equation essentially would become, by following the BODMAS rule, the value of x that I want to find out will be, the value of x would be 0. Now, if I was looking at taking another equation wherein obviously the value would not be 0, what I would then do is obviously change this slightly, because both the variables are x in this case. If I were to look at taking another equation, and I would change the value here slightly, put a new slide. Sometimes you have, two different variables in an equation. So 3y equal to 4x, if this was the equation, and how would I solve this? Because we want to know what is x and what is the value of y. So what we would do is, basically sometimes in questions that you get in maths, you will have these kind of equations, and what you have to do is sometimes explain the steps in solving the equation. And what you need to know is primarily the rule of BODMAS to be able to sort or basically solve this equation. So here again, if we have to follow the BODMAS rule, what we will essentially look at is finding the value of y, right? And how would I go about it? So here step one would be to always look at solving the bracket first. So we know that if I write the equation 3y equal to 4x multiply, it is going to be 128 divided by 2. That will be the first step. The second step after that will be, after brackets you have division. So again I will write 3y equal to 4x multiplied by 128 divided by 2, that is 64. So this becomes the second part. The third part now is, after division I need to solve multiplication. So what I'm going to do in this case is, I'm going to look at solving this particular equation by looking at multiplying. So 3y equal to 256x, because I multiplied 64 by 4x, and that will become 256x. Now, how do I isolate the value of y? Because I want to find what is y equal to. So what I'm going to do is, I'm going to say y equal to 256x divided by, because what I will do is, I will basically 256x, and here what I'm going to do is take the 3 on the other side. So when I switch the 3 on the other side, what I would primarily do is look at moving the value of 3 underneath in terms of denominator. So sometimes when you represent fractions, you write 33 and then you have a line in the middle, and then you say 45. So this is a fraction essentially. So how would I change this number into a fraction? What I'm going to do is take the 3 from the y and I take it to the other side. So I will take it to the denominator. So here the equation will become y equal to 256x divided by 3. So if I have to write it this way, what I will do is I will write it like this, divided by 3. And that would become the value of y. Now, if the question was to find the value of x, you would do the other way around. So what I will do is, I will say x equal to 3y, and then I will take the value of 256 to the other side, which is 256 divided by 3 divided by 2, 3y divided by 256. And if I have to simplify it further, we'll check if 3 is divisible, 256 is divisible by 3. So 3 7 is 21, 3 is 24, 1, and 3 5 is 15. So this will remain this number, because otherwise if we divide 3 and simplify this fraction again, what will happen is it will go into decimals, which we don't want. So here you can use the BODMAS rule to either find the value of x or find the value of y, and that is how you would go about doing it. And this is what we need to understand when we talk about expressions in general. Is that okay? So if I were to look at now explaining by taking a few more examples, expressions, equation, and formulas are essentially used in mathematics to work out something, to find out the value. For example, practical, applications. If I have to talk about practical applications of expressions that we can use in maths, and where all can we use that. So if I talk about practical applications, we use them in budgeting and finance. For example, you would want to calculate the interest, assuming you are looking at buying a car, and that car you are buying on a loan basis. You would be looking at using equations and formulas and calculating percentage of interest that you are going to pay on the loan that you would get to buy the car. So this is a practical application of where we would use expression, equation, and formulae. Now it can also be used, I would say, in physics and engineering. Now when we look at say for example, calculating the speed at which something falls, one of the Newton laws, I don't know whether you recall, but when we've studied in school, we've learned the 3 laws of Newton. One of the laws, his second laws, was the speed at which things travel, which was force. So if you have a ball in your hand, or if you have say for example, a glass in your hand and you drop it accidentally, how quickly it falls to the ground and it breaks will actually be calculated by using Newton's second law, which is the expression of force. When you're driving in the car, and sometimes you see this video which shows that if you're driving at 30 miles per hour, if you hit somebody, this is how far they will be going or falling off. If you're traveling at 10 miles per hour and you hit somebody, this is how far. So what they're trying to do is calculate the force with which your car, which is a moving mass, because at the end of the day, it's a big object and it's moving with speed. If it hits somebody, how far they would be falling or getting affected. So in this case, you can use expressions, formulas, and equations to, calculate, say, force using Newton's law. Sometimes you also look at using it to calculate voltage, in electricity, which is basically the Ohm's law. So you have sometimes as parents we see that, okay, my kid studies, and obviously they study on a study table, the table lamp light is too less. So what you would normally do is you'll check what is the wattage of the bulb. Oh, it's a 20-watt bulb, it's a 15-watt bulb, I think we need a higher wattage. You will probably go out to the market and get a 40 or a 60-watt bulb. So when you have to calculate what is the wattage and how much light would that wattage of bulb give, you would again use an expression or an equation or a formula, and that would be the Ohm's law. And that Ohm's law will be voltage equal to current into resistance, and that will help you calculate what voltage of bulb will provide how much, or use how much electricity, and how much light, in a sense, in lumens it will produce. But general usage of equations and formulae, we would use them predominantly in finance, business, and economics, for profit calculation, for example, for break-even analysis, for the rate of interest that you're going to pay on your mortgage or on your car. You would use these situations, practical situations, in which you would always be confronted by giving certain variables. So when you go to the bank manager and you say, okay, I want to buy a house and I want a mortgage. So the bank manager, you would first question that you'll ask the bank manager or the concerned person would be, what is the interest rate on the mortgage today? Then they are going to tell you, okay, we want a fixed mortgage or a variable mortgage. And then the further question could be, do you want a 2-year fixed mortgage? You want a variable mortgage? You want a 5-year fix? You want a 10-year fix? And then they will tell you what is the rate of interest at which the mortgage interest would be charged. So if you look at something about 2 years, they would basically say the Bank of England base rate is 4%, and on top of it, you're looking at paying 2.25%. So the total interest rate on the mortgage for a 2-year fixed would be, say, 6%, 6.25%. Now, this 6.25% is a number to you, but how do you look at finding out how much would it be costing you to pay every month in terms of installments, monthly payments? That is where your expressions would come in handy, because when you calculate mortgage, and what are the things that in terms of variables? The interest rate. So this is one of the variables. Now, if the interest rate changes from 6% to 7%, your mortgage will rise, right? You would also need to know the Bank of England base rate. Now, these are variables which are going to be, things that you would need to know essentially before you calculate your mortgage. So interest is, say, they're going to charge 2.5%, 2.25%. And on top of the Bank of Base Rate of England, then you would essentially have your total mortgage rate, interest rate would be 2.25 plus 2, which is 4.25%. Now, okay, I know that the interest rate which they're going to charge is 4.2%. For example, this was Barclay. You know that they're going to charge 4.25%. But how does this help you calculate what are your monthly payments going to be? So the next variable or information that you will give to the person would be that the house that you're buying, house value, that the house that you're buying, you'll probably give the person the house value. So the house that you're buying, say, for example, is 450,000. You're buying a detached house, and the cost of that house is 450,000. Then the next question or variable in terms of information the person would ask is, what would be the minimum deposit that you need to put? So in most cases, bank would say you need to put 20% of the deposit. Now, all these are variables, right? It is not actually giving you the literal information, which is what would be my monthly payments, right? Which is what we are interested in finding out. Now, once you have these variables, what we need to be able to do is then put them into what is called, some sort of an expression, that These variables are available. Now I know what is the interest rate, what is the bank going to charge, what is the value of the house, and what is the minimum deposit required. These are all going to be what are called, if I put this here, variables. Now, once we know the variables, we then need to put this into some sort of an equation, which is where it will come, wherein what we will then look at is what is called an expression. So, how would we look at making use of this data to make it meaningful for us? The first and foremost thing that I'm going to do is I'm going to look at calculating some values. Now, what is 20% of 450,000? That is the first thing that I need to know, because I want to put something in terms of meaningful information I want to get out of this. Now, if I were to look at 20% of 450,000, that would be 90,000 is what is going to be the initial deposit. Initial deposit that I need to put to buy the house. That means step two, that means bank will loan you how much money? 450,000 minus 90,000 equal to 360,000. That is the loan or amount of mortgage that you need, correct? So 450,000 minus 90,000, which is the initial deposit of 20%, you need 360,000 as the loan. Now, this is going to be making sense because we know these variables, and from these variables, we are trying to convert this into a meaningful information. And now I know some part of it is coming through. Now, what we know, step three, what is the interest rate? Interest rate is 4.25%. Right? So if I have to now calculate the monthly payments for a mortgage, which is where I know house value is 450,000. Initial deposit, that you're required to put is 20%, 20%, and we know the interest rate is 4.25%. Now, what is the tenure of the mortgage? One of the important things, the bank person would ask you is how long do you want the mortgage? Normally, because it's a big amount that you are looking at paying, you would normally spread the payments across to 20 or 25 years. So they will ask you what is your age, they will ask you how long can the mortgage be possible, and in most cases, if they say the tenure, of the mortgage is going to be related to your age when you turn 60, so assuming it is 20 years, right? Now, if you know all this information, I can now calculate the monthly, payments. So here, what I'm going to do is what are the monthly mortgage payments going to be? That is what I want to find out. So calculate the monthly mortgage payments. That is what I need to essentially do. Now, when I know this, I need to now convert this information into what is called some sort of a formula. So step four is, calculate the monthly mortgage payments. Now, even after having all this information, I cannot still calculate, the monthly payments. So what I now need for my final part of the expression is a formula, and that formula is going to be something which will help me calculate my monthly payments on the mortgage. Are you with me so far? Is everybody able to understand?
I'm a bit confused here.
Yeah, go on, ask a question.
Beginning, you said the interest will now be, let me see, the total mortgage rate will be 4.25.
4.25, sorry, yeah, correct.
4.35, so I'm getting a bit confused.
No, there's a typo error. So interest rate is 2% plus 2.25, which is 4.25. So the interest rate is 4.25. Is that okay? Not 4.35. That was a typo because I'm typing. Yeah.
I'm
So
okay. Thank you.
Now, what we need to do is we need to find out what is the formula which will allow me to actually calculate monthly payments for this mortgage, right? If I know that my loan amount is going to be 360,000, I'm going to pay an initial deposit of 90,000. The total house value is 450,000, and the interest rate is 4.25%. I am going to get this mortgage. So here first, so here what I would also do is, and the tenure of mortgage is 20 years. So I know that I'm going to be borrowing 360,000 from the bank for 20 years. Now I need to know the formula to calculate the monthly payments. That is what I need. So what the formula would be? Now this is a standard formula, and that is something that we need to know to be able to put this across. And that is where formula will expressions will come. So these are all variables which form the expression. Then you have the information, which is primarily your helping you to get to some sort of an equation. And finally, you will need to look at a formula to calculate the mortgage. So here, loan amount multiplied by interest rate, which is 4.25%, and then further multiply. But here, what I will do is 1 plus interest rate, because you will start with first monthly statement and then multiply by loan term months. So I will convert the 20 years into months. So each year has 12 months. So if I look at 12 multiplied by 20, we are talking about a mortgage being total of 240 months. That means because we are wanting to know, why do we need to convert years into month? Because I want to know what is my monthly payment going to be. So I can't have apples and oranges. So I have to look at converting the years into months, because my aim is to find out what my monthly payments are. If you are looking at finding out yearly payments, assuming all yearly payments, how much you would pay on a year, back to the bank, then obviously you could all leave that variable as 20 years. But because I want to find out monthly payments, I would need to convert the years into months. So each year has 12 months, and we are talking about 20 years as the length of the mortgage. So 12 multiplied by 20 equal to 240 months. And here, then in the formula, what I will do is close the bracket. I'm going to divide this by, again, 1 plus interest first month plus interest rate multiplied by loan term months, term months minus 1, close the bracket. Now this would essentially give us the calculation in terms of what my monthly payments would be. So my monthly payment M equal to, considering these are the values, that the loan amount is 360, the interest rate is 4.25%, and my tenure of the mortgage is 240. This, if we put by this particular formula with a 20% deposit, my monthly mortgage payments are going to be 229.49 penny. That is going to be my monthly payments, repayments of the mortgage, considering that you're buying the house with this value, 450,000. That is the interest rate. These are the years in terms of interest payments, number of years. That is how you will calculate your monthly payments to the bank. Now, why this is important? As you can see, the business usage of expressions on a day-to-day basis is to look at practical calculations to get or to arrive at answers which will include things like, mortgages, repayment of your car loan, or for example, if you have taken any loan from the bank as a personal loan, repay it back, what will be your monthly installments. If you buy something on credit card, for example, you bought some sort of an expensive furniture for your house, and the furniture costed you £10,000, but you don't want to pay £10,000 next month because you want to bring it or stagger the cost. So what you will do is you'll do some mental calculations, but what you're going to do is calculate that, okay, if I pay only 2,000 every month and cover this cost across 5 months, then what will be the interest rate I would be paying, and how much would be the extra money that I'll be paying to the credit card company. So that is where you would use the expressions, equations, and formulae for to calculate this, to see whether it's worthwhile, or should we look at sending this across, or making that payment across pretty much straight away. So practical applications, if I have to summarize. Now, another practical application before I do this example would be to look at, sometimes when you look at expressions, you look at this in the case of sports and fitness as well, right? For example, I was looking at running the Manchester Marathon, which is going to happen in the month of July. And that's a 10K marathon, which is 10 kilometers marathon. And I was looking at, preparing and obviously getting fit and into shape for that marathon. Now, one of the things that you would want to calculate is that you want to finish the marathon, this 10 kilometer long marathon that you want to participate in. You have done this earlier as well, just as an example, but what you want to do is you want to finish it in a certain amount of time. You don't want to be, taking 1 hour to complete it, but what you want to do is improve on your time from previous years. And this time, what you want to do is, say, complete that 10-kilometer run in, say, under 1 hour, right? Now, how would you do that? Again, you would need to make use of expressions in terms of formulae and get some variables in place. So here, when I'm looking at running, I need to look at speed. I need to know the speed. I need to know the distance, and I need to know the time. These are the three variables that you will look at specifically for calculating, that how long will it take, or how fast would I need to run in terms of being able to complete the marathon under 1 hour. Now, you could have some values that you could give to these variables. And for example, I want to calculate at what speed I would need to run. I know the distance is 10,000 meters or 10 kilometers, km, as I look at the symbol. And then what I want to know is that what is the time at which I would be able to, run this. Last year, for example, I did complete this marathon in 2 hours. So how do I calculate my speed? Now you need to know the formula. The formula is speed equal to distance up divided by time. Now, if you know this formula, then you can calculate what speed at which you ran last year. So how would we calculate speed? So speed, if I put it this way, speed equal to distance. Distance was 10,000 meter and divided by 2 hours. So 2 hours, what I need to do is, if I look at, this is something that you need to know, and that is an information that you will need to learn and, obviously memorize. Now, when you look at distance, if the variable is given in kilometers, then you would use hours. But if you are given the distance in meters, then you would need to use what are called minutes. So you have to look at equal parameters to be able to compare to get to the right solution. So if I was given distance in meters, I will convert time into minutes, because these are smaller units. So I will need to look at that. If I was given distance in kilometer, then I will use time in hours. So that your answer is correct, we need to know the variables and how they can be used, in what units they can be used within the formula. So in this case, when I know the distance is 10,000 meters, what I would do is I need to convert this 2 hours into minutes. So each hour is 60 minutes multiplied by 2. That means total minutes would be 120 minutes if I ran this. Now, if I have to simplify this in terms of the speed which I ran, so speed is normally in kilometers per hour. If the variable that you're trying to calculate is in kilometer per hour, then you will leave it as it is. You will not calculate minutes, and you would use just the distance in terms of kilometers. So 10 divided by 2 equal to 5 kilometer per hour. That is the speed at which you ran. But if you are wanting to find out this in a bit more detail in terms of how long is it taking for you to run 1 kilometer, and then look at improving your times across it, then you would use 10,000 meters divided by 120, and that will give you your speed essentially in minutes, in meters per second, and that would essentially be allowing you to calculate how much were you running or how fast were you running, every kilometer. So in that case, your speed would be 83.3 meters per second. That means you are actually covering 83 meters in 1 minute. So you were trying to run like Hussein Bolt, for example, runs 100 meters in under 11 seconds, but you were running obviously approximately 1 kilometer in about 83.3 seconds. So that would mean, if you want to break it down further, what you are going to do is convert the time that you have in minutes to seconds. And you know that 1 minute is 60 seconds. So if you had 120 minutes for the hour, that you will multiply by 60, and that will allow you to get your time, that how fast you were running in meters per second rather than meters per minute or meters per hour. Is that okay? So the unit in which you want to calculate your answer or get the answer, you have to look at converting the numbers given to you or the variables given to you into those units first before you look at finding out the right answer. And you also need to then know the formula through that you are going to use to be able to solve that particular expression or equation. Now, the practical applications of it, are many, and this is what we get to see in our day-to-day lives. Sports and fitness is one such example. Mortgage and interest rate or payments when you buy something like a car, or you are looking at buying a house on mortgage, is another example. I gave you some examples of another example that I can give you, which will be, for example, where do we use expressions is when we look at calculating BMI. Do you know what is BMI? Anyone?
No.
Okay, BMI is when you go to your doctor and he says that you're obese, you're eating too much, you need to reduce weight. So they look at your
What
body
is
mass
body mass
index.
index?
Yes, body mass index. So when you look at calculating your BMI, again, you're going to use expressions and formula. So how do you calculate your body mass? You need to know your weight. That is the first variable. You need to know your height, which is the second variable. And if you know these two, weight, say for example, in kgs or stones, you have to look at the units in which you are going to calculate, and then height in terms of centimeters or meter, and that you have to use the units accordingly, and that is going to help you calculate your BMI. So BMI, what is the formula? BMI is weight divided by height, and that will give you your BMI. So if I know my weight, for example, is 70 kg and my height is say 1.75 meter, then my BMI is going to be 22.86 if you solve this equation. And that would mean I'm not obese. I'm within the healthy range of being non-obese as a person. But if your height, if your weight was, for example, 100 kg, and your height was 1.75 meters, so if you divide 100 divided by 1.75, your BMI is going to be 57 point 57 point say 12. So you are going to be obese. How do you know you are going to be obese? So the BMI index basically has an indicator or a chart, and that chart, BMI chart, sorry, not obese chart, BMI chart. And BMI chart says if you are over 35 in BMI, then you are overweight. So if your height was 1.75 meter and or 175 centimeter, and your weight was 100 kg, then your BMI will be 157 or 14. That means you're highly obese. You need to reduce. You are at very high risk of diabetes and heart attack and coronary disease. So that is where you would see the practical applications of expression, equation, and formulae. So sports and fitness, medicine and health, you look at business, you look at finance and budgeting, you look at places where you're going to be looking at physics and engineering. These are going to be practical areas where you're going to be using expressions, which are going to be then equations and the use of formulae. Is that okay?
Uh,
Any questions?
how do you convert this body mass index to stones?
Okay, so you need to know basically how many stones is 1 kg in a kg. For example, sometimes the American way of measuring weight is primarily stones, or sometimes they use what are called pounds. So we need to know and remember this. This is where you need to know the formula or the conversion of the numbers. So we know that 1 kg is equal to 0.15 stone. That is the conversion. So if you know the for conversion of 1 kg, and if I know that somebody say 75 kg, how much are they in stones? So if I put this particular bit 75 kg, then I would know that 1 kg is 0.015 stone. What is 75? So 1 divided by 0.015 into 75, that would give me stones. So that would be for 57.14 stones. So you need to know the units, and you need to be able to know the formulae. So if you know the units and if you know the formulae, then it will be easier for you to essentially, um, uh, you know, um, find the answers to the question. Now, there is a formula handout that I have. Let me just show you that. 1 second. Formula handout. And that formula handout is something that I would say I would, ask you to have at hand, and obviously use it for the purposes of, I would say remembering it, because these are commonly used formulas that we end up using in our day-to-day lives. So I will share this particular formula handout with you, which is for various types of calculations that you need to do. For example, you need to find out averages, range, and median. Sometimes, you want to find out, okay, sometimes you go to the market and you want to buy potatoes, or for example, you want to buy some grocery. So what you want to do is you want to find out, today I bought potatoes at 2 pounds. Yesterday I bought it at 1 pound and 50 penny. 3, 4 days down the line, the prices have risen, you bought it at 5 pounds. So what you want to find out is what is the average price at which potatoes are being sold in the market. So what you will do is you will use the formula to take out an average. So these are important and commonly used formulas that I've created a bit of a handout which has been taken from SkillsWise website, and what I've done is I've compiled some answers and examples into it where you use these formulas. How do you calculate mean, median, mode? How do you calculate the formula of, say, say for example, a triangle or a rectangle? In some cases, how do you calculate interest rates? And these are given in this particular handout. So I'll share this with you just after this session. And what you could use is, I'll put it on WhatsApp right now in the maths group, and you could actually use this, in the future, because this is something that you need to remember. And if you know these formulas, then only you can calculate, the required, or solve the required equations or expressions. Is that okay? So I put this formula on the WhatsApp group. Any other questions? Any other questions if anybody has? Okay, so in this particular presentation that you're going to see, there are a few examples that are also given, how to look at equations, how to look at solving the formulas, and where all practical applications, like I've explained, you use or have formulas. So my suggestion would be to go through three, four of these slides, which is basically showing where formulas are used. For example, if you have to convert the temperature in degrees to temperature in Fahrenheit. Now, in the UK and mostly in the Europe, we talk about temperatures, in centigrades. But in the US, they talk about the temperatures in Fahrenheit. But if you have to convert, say, today the temperature is 16.5 degrees, but what is it in Fahrenheit? You need to know the formula to be able to convert that to Fahrenheit. So Fahrenheit, if you have to convert the degrees into a Fahrenheit, then the formula is this. F, which is Fahrenheit, equal to 9 by 5, centigrade plus 32, and that will give you the temperature, in Fahrenheit. Similarly, when you have to look at sometimes, you say that, okay, I work on a hourly wage and I work on a contract with this particular, Tesco stores, for example. Now you want to calculate what are you being paid on a monthly basis, or what would be the total number of total wage that you will get at the end of the month, considering you work, say, 25 hours in the store. So again, there will be a formula for it. So your employee pay for that particular month is going to be hours multiplied by the hourly rate, and if you do any overtime or if you get any bonus, that will be added on top. So your wage would be calculated into hourly rate multiplied by the number of hours that you have worked for that particular organization. So these are places, again, examples where you actually calculate and use expressions on a day-to-day basis. Like you're doing a taxi, you're taking a taxi from your house to the airport. You want to find out what is the taxi fare. You would obviously ask the person how much would they charge. They would normally have a flat charge of 25 pounds to taking to the airport. But if they don't have a flat charge, you might ask the question to the taxi driver that, okay, how much is it going to be approximately, just to make sure that I have enough change to be able to pay you if you're not accepting card payments. Then he can tell you that, okay, the per kilometer charge is roughly about £6, and then there is a standing fee of £3 for the taxi. And then you would look at, okay, mentally calculating from Huddersfield, or for example from Oldham, if I have to travel to Manchester Airport, it would normally take about 45 minutes on a busy road, in a busy traffic. So what you would do is calculate, okay, 45 minutes, and he's saying it's £6 an hour, £6 a kilometer, then it is so much kilometers to travel. And again, you would use a formula and an equation to essentially arrive at this calculation of how much would it take for you to take a taxi from Oldham and go to Manchester Airport, and how much would it cost you. So these are some practical examples which I've given in the slide, which I would suggest that you go through after the session, and this would help you to understand the usage of expressions and usage of, equations and formulae with regards to today's topic. So any questions on this so far before we end the session? Any questions? Okay, so this was the 2-3 slides that I was referring to, where you use temperature conversion from centigrade to Fahrenheit, looking at calculating, say, for example, hourly wage, or the total wage that you would get, and then an example of the taxi fare, which I was mentioning. So if there are no more questions, I'm going to try and end the session now, and we'll see you next week, where we'll cover another session for another topic, which will be fractions, decimals, and percentages in maths. So till then, my suggestion would be, if you log on to Moodle and go on to Moodle and obviously look at the math section, wherein it has 1 or 2 short exercises or activities that I've given in order for you to understand this in a bit more detail. And that would be useful if you go in and obviously look at the expression. So let me show you that very briefly. Just give me 1 second. So if you look at logging into the Moodle, and when you've logged in, just say collapse all. So today we have covered, this particular part, which is expressions. So in expressions, this is a video that I would suggest that you watch, which explains and summarizes what we have covered today. The presentation that I've looked at is given here. And then there is an activity that I've given, which is what you can download as a Word document along with the answers. So what I'm going to do is obviously unhide the answers, so that once you've completed the activity, you can actually check in terms whether you've got it right or not. So that is the bit that we have looked at covering today, which is expressions. And obviously, thank you for joining this session. I will see you next week. So enjoy the rest of your day. And if you think of any questions, or if you have any questions after the session, you can actually send us an email on learnerwork@UK and I can get back to you with more activities that will help you understand today's topic, or handouts if required for understanding today's topic. Okay.
Okay. Thank you
Okay.
so much.
Thank you. And I'll send the copy of this recording of this session just after when we close onto the WhatsApp group so that you have it if you need to rewatch it.
Okay.
Okay. Take care.
Thank
Thanks.
you.
Thank you. Bye.